Now, in this video, we are going to take up one more problem on projections of lamina. The front view of a rectangular lamina of size 30 mm by 20 mm is a square of 20 mm side. Draw the projections and determine the inclination of the surface of the lamina with HP and VP. So, how to do this problem? How to analyze this problem and solve it by using the manual method, that is by using the sketchbook. So, to do that, first we will go for the front view of a rectangular lamina. So since he says it is the front view, so obviously we need to start from the vertical plane of a rectangular lamina of 20 mm by 30 mm is here. So when you look from the front view, you will going to get a square rectangle of this is the 20 mm side and this is the 30 mm. Is placed such that it is parallel to VP and perpendicular to HP. So when you look from the front view, you will be able to see the true shape of ABCD, and it is projected directly onto the vertical plane of A dash, B dash, C dash and D dash, which is 20 by 30. Then when you look from the top view, you can see there is a line here. When you project it, that will go to falls on the horizontal plane. So which is A and B is near to the observer, it is visible, and C and D is away from the observer, so it becomes invisible. So what is the position of this rectangular lamina? The rectangular lamina is of 20 mm by 30 mm, and here the surface of the lamina is parallel to VP and it is perpendicular to HP. Since it is parallel to VP, you can see the true length in the vertical plane. As you look from the top view, all the sides, that is AB, BC, CD and DA, all the sides are parallel to VP. Since it is parallel to VP, you are getting the true length in the vertical plane. So this is how you will be able to analyze it in 3D. How to solve this? By using 2D. First I will going to draw an XY line and I will going to mark VP and HP. So in VP you measure 20 mm vertically and then 30 mm horizontally. Then you construct a rectangle by using the sketchbook, wherein you can measure it directly. Then you mark these points of A dash, B dash, C dash and D dash, and you mark the distance of dimension 20 and 30. Then you take some distance from the XY line in the top view and draw a horizontal projector, and draw a vertical projector from A dash and D dash, and draw a vertical projector from B dash and C dash to the line drawn parallel to XY line in the top. Then you mark these 2 points. AB is near to the observer, it is visible, and C and D is away from the observer, therefore C and D is in bracket. Then join between A and B with a dark line. So this is how you will be able to write the initial position of the front and top view in the first position. Then it is rotated such that the front view is seen as it is rotated such that the front view is seen as a square of 20 mm side. So here this 30 mm will go to become 20 mm. So this 20 will remain the same. So first what I need, so you have to rotate this initial position such that when it becomes inclined to VP, till it becomes a square of 30 mm side, 20 mm side. So this is how you will be able to analyze it. So what is the position of this rectangle with respect to VP and HP? With respect to VP, it is inclined to VP. If it is respect to HP, it is perpendicular to HP. Therefore, you are getting a line in the top view. And whereas when you look from the front view, it becomes a square of 20 mm side. This is not a true shape, it is an apparent shape, because since AB becomes inclined, so A dash, B dash will be in apparent line. Both BC and AD is parallel to VP, so you are getting these two in true length. Similarly, CD is also inclined to VP, therefore you are getting the apparent length. But in this case, this side is also 20 and this side is also 20. So obviously B dash, C dash and A dash, B dash, D dash is already 20 mm. So this is how you will be able to analyze it in 3 dimensions. Then how to write this? So first you draw a horizontal projector from A dash and B dash, and you again from C dash and D dash in the second position to front view. Then you take any line from any point on this horizontal line and mark that point as A dash. then draw vertically down so that you are going to get this D dash. Then with A dash center, take the radius of 20, draw an arc, and similarly from D dash also you draw an arc on that horizontal projector. And you mark that point as B dash, and you mark this point as C dash, and then you mark this point as D dash. Then join A dash to B dash to C dash, C dash to D dash, and D dash to A dash with a dot line. Show the dimension of square 20. So once you do that, when it will going to be getting a square, when the top view of the rectangular lamina being inclined. So you draw a vertical projector from A dash and D dash and draw a horizontal projector from A and D. Both these two lines will going to intersect at this point. Then you draw a vertical projector from B dash and C dash to the top view. Then you measure the distance from A to B with A sector cut on this vertical projector, and you mark that point as B and C in bracket. Then join A to B with a dot line. So once you do that, since you have given the surface inclination with respect to HP and VP, what I need to do, you need to rotate this by an angle of 90 degrees, which is as shown. So that means it is rotated in counterclockwise direction such that A will become here, D will become here, C will become here, and B will go to become here. So once you do that, so this is the rotation of this rectangular lamina in space. So if you project this, when you look from the front view, this will going to be A dash, and this will going to be D dash, and then this will going to be B dash, and this will going to be C dash. So it will become, say, again it is a square of 20 mm side. So here he says, since it is the surface inclination with respect to both HP and VP, so obviously that surface has to be perpendicular to the profile plane. So that is the reason why we are writing the profile plane here. So when you rotate it and keep it, and when you look from the side view, since the surface is inclined to VP and also the surface is inclined to HP, so therefore once it is rotated, since it is inclined to both HP and VP, obviously this rectangular lamina is perpendicular to the profile plane, which is this profile plane. RPP is here. So therefore you will going to get a line in the side because it is perpendicular to profile plane. Then as you look from this end, AB is near to the observer, A double dash and B double dash is seen, C and D is away from the observer, therefore C double dash and D double dash is in bracket. Then you measure the inclination with respect to HP, which is theta, and you measure the inclination with respect to VP, which is the phi. So this is how you will be able to analyze this problem on 3 dimensions. Similarly, when you look from the top view, you can see A, B, C, D is resting on HP. But here, when you look from the front view, A dash, B dash, C dash, and D dash are will going to be a square again. So this is how you will be able to analyze this problem in 3D. Now how to write this as a solution in third position. So what I need to do is, we need to rewrite the same sketch by rotating at an angle of 90 degrees. That means A dash, B dash will going to become vertical now. A dash, B dash is will go to vertical. B dash, C dash, which is vertical, will going to become horizontal. And then C dash, D dash, which was horizontal, it will going to become vertical. And D dash, A dash, which is vertical here. Therefore, you are going to get the top view. That is, the front view with A dash, D dash, and B dash, C dash. Then you draw a vertical projector from A dash and B dash, and draw a horizontal projector from A and B. Both these two lines will going to intersect at this point and this point, which is A and B. Similarly, draw a vertical projector from C dash and D dash, and draw a horizontal projector from C till to this point. Similarly, from D also you extend that till here. So you mark these points as A, B, C, D. Then join A to B, B to C, C to D, and D to A with a dot line. So once you do that, now it has become the surface is inclined to both HP and VP. Since it is surface is inclined to both HP and VP, therefore I need to construct the profile. So you take any convenient position. You take any convenient position from the third position front view. Draw a x1 y1 line, and similarly you extend this xy line, and you mark this point as profile plane. Then through the origin with respect to the xy, measure an angle of 45 degrees by using the protractor. Then you draw a line. Then join between A and D to the 45 degree line, and from here you project it to the side view, wherein you have A dash and D dash. So as you look from the left side view, so you're going to get A double dash is visible and D double dash is invisible. Therefore, A double dash and then D double dash is in bracket. Similarly, draw a horizontal projector from B and C to the 45 degree line, and from this 45 degree line you take upwards to the profile plane. And since it is BC, where is BC? BC is here, that is B dash C dash. Draw a horizontal projection from B dash and C dash. Both these two lines will going to intersect at this point. As you look from this, so B double dash is visible and C double dash is invisible. So then you join between A double dash and B double dash with a dark line. Then the inclination with respect to the horizontal is measured as theta. The inclination with respect to the vertical plane is measured as phi. So by using the protractor, with reference to the vertical, you measure the angle. So once you measure that, you are going to get phi is 48.19. So 90 minus of this value, 48.19, will going to give 41.81 degrees. So the sum of these two angles should not be greater than 90 degrees. That is your the final thing which you can be able to write. How do I know that my problem is right? The problem here, he has given the surface inclination to find out with respect to both HP and VP. It will going to be a complementary angle. The sum of these two angles should be always equal to 90 degrees. Then it's a square till the rectangular lamina of 20 by 30 is rotated such that till it becomes a square in the front view. So that is how, since we have incorporated all the data which was given in the problem, and hence my problem is right. Thank you.